So I'm Tom Kane. I think I know most of the folks in the room, but I'm faculty director of the Center for Education Policy Research here. At the PIER seminar, I just wanted to remind people that this is being recorded. So don't say anything that you wouldn't want to see living on the website. I know I don't need to tell Jeff that, but maybe I know just looking around this room, this is a hardened crowd, and so just warning you that your questions will be recorded. Also, we'll be doing this what we started to call econ style, where if you have questions in the moment, you can raise your hand and Jeff can answer. If we've slowed Jeff down, I will intervene and just say, okay, let's move along. But if you do have certainly clarifying questions, but even bigger picture questions in the moment, you should feel free to ask. Okay, so now I just want to give a welcome to Jeff Denning, our speaker today. Jeff is an associate professor at the UT Austin LBJ School of Public Affairs. He studies economics of education. Today, he'll be talking primarily about K-12, teacher grading practices and long-term outcomes for students. But a lot of his work is focused on higher education, and I know we have people in the room that are similarly focused on higher education. Another thing to know about Jeff, especially for the graduate students here, is that Jeff directs the Education Research Center at UT Austin, which has access to the administrative data throughout Texas. And so for students who are interested in doing work with Texas, Jeff would be a good person to know. So thanks, Jeff, for joining us. I know it's much colder than in Austin, so thank you for having the courage to get on a plane and fly up here.
Thank you very much for having me. I'm really excited to be here. One clarifying, I don't direct I am a research director. There's a director who is my boss, so I don't want to step into that. So anyway, thanks so much for having me. Really excited to discuss this paper. This is with several co-authors, Rachel Nesbitt, Nolan Pope, and Meryl Warnick. And we're going to talk about grade inflation. So Tom mentioned I mostly am interested historically in higher education, and actually kind of the origin or an origin for this paper is kind of my interest coming from higher education. So I wrote a paper with Meryl and others about college graduation rates, and we said why they're going up, why are they going up, and we concluded the answer was grade inflation. The question that we most often got about that paper was, is this good or bad? And we were like, I don't know. We think it's important to document and figure out, but we're not sure if it's good or bad. And that was in the back of my mind for a couple of years. And this project grew out of kind of wanting to try to answer that. Now, of course, it's a different setting and that sort of thing, but we're hopeful that the insights from this might yield some insight into the mechanisms that grade inflation, the mechanisms of grade inflation. So that's a little bit of a preamble. So average grades have been rising. This is true in college, so you can see that that's the circles. And it's also true in high school. Okay, so this is just two nationally representative surveys, and you can see grades are going up. You know, when we first started, sometimes when we talk to people about this project, they're like, this is a college phenomenon, this is not a high school phenomenon. It's a both phenomenon is kind of our argument. You know, this is not evidence of grade inflation per se. That's a loaded term. I should comment on that. Inflation, it's just going up here. That could be going to the correct level or something like this, but it is going up. Now, you could think that achievement is going up at the same rate. That's a pretty large increase in achievement. That's, not matched and kind of measures, other measures such as test scores or that sort of thing. We're not going to comment on that so much, but just to say this is happening both at the higher ed level and the high school level. And stakeholders are pretty concerned about this impact. In the higher ed space, there have been recent high-profile reports, one here at Harvard. You guys probably know more than I do about the details of that. And then also UCSD had a report that got a lot of attention recently in higher ed. Similar discussions, in some ways similar discussions, are happening in K-12 as well. They use different terms. Sometimes this is focused on equitable grading, which is a set of practices around grading that tend to increase grades. Okay, and so it's an active policy question, I guess, is the motivation there. But it really depends on what the effects of this are in terms of how you should think about the policy. So we're going to focus on teachers in this talk, and one reason we do that is teachers have a lot of discretion over how they do grades. I'm a professor. I have a lot of discretion about how I decide exactly where to put an A or an A minus, et cetera. You have basically a continuous measure of student achievement in your class, and then you're making decisions about how to assign grades to that. So that's like, in the limit, it's like infinity degrees of freedom. You can have lots and lots of choices that you can make, right? And so we're interested in the effect of grade inflation. What's the effect of being assigned a high school class with a higher level of grade inflation, and then how do students respond to these relaxed grading standards? We're going to have to do a lot of things to get to that, but that's kind of where we're headed. I guess I already said this first. That happens a lot when I give talks, is I'll say the slides on the next bullets. But, it can take many forms because you have this kind of many choices you could make. And so here's some examples. You could have just a teacher who is generally an easy grader. They generally give out easy grades. You could have a generally difficult grader, okay? But you could also imagine kind of lots of different ones. We're going to highlight one in particular here, which is it's easy to pass, but it's difficult to receive an A, right? Or you could make it difficult to pass, but easy to receive an A, or, comparatively, right? So you have all of these choices. We're going to focus on kind of the passing margin later, and so that's why I raised that now. But there's a lot of different choices that teachers make. The impact of grade inflation is theoretically ambiguous. There's some nice theoretical work on this by Kostrel and Betts, among others. And the general idea, the general mechanism, there's specifics in those papers, but the general mechanism is that incentives or high standards could incentivize students to invest and learn more if they're near the margin of, a higher grade, okay? But it also could discourage students who, if I increase the standard, it's too hard for me to get to that standard, and so I'm going to then reduce my effort and then potentially, learn less. Okay, so it's kind of theoretically ambiguous. These two papers are really great. I think, kind of classics. But they, in both cases, are thinking about a single passing standard. And it actually gets even more complicated if you were to have two standards, or let alone however many letter grades there are. So it's not obvious exactly how, I think there's a reason that they focused on a single standard, because it's hard enough to kind of get all of the predictions there. But I think that the general idea that some people will be incentivized to exert more effort and some will be, disincentivized, potentially, or discouraged, that I think is a general thing to keep in mind there. So it can depend both on the student characteristics, but also on the type of inflation. So you could imagine that a passing grade inflating has maybe a different effect than kind of overall, mean grade inflation. So we'll come back to that idea. And the other thing is that, so this is all to say it's ambiguous. You need data to answer this question. And so we don't really know with existing research what the effect of grade inflation is on net. And, or if it's heterogeneous, what are the different effects for different people? By the way, I should say, I definitely like questions. It makes me, less nervous if you're asking questions. So, be your most econ style questions if you want. Okay, so what does this paper do? We're going to construct and validate two types of grade inflation measures. And I'll talk more about these later. We're going to have mean grade inflation, so kind of general teachers give generally higher grades versus passing grade inflation, which is teachers are more likely to pass their students. So that's the first thing, is we're going to develop those. We're going to validate those in some, in some ways. And I think we'll learn some interesting things there. And then the second question is, how does this relate to other teacher characteristics, in particular teacher value added, a couple of different kinds of teacher value added, cognitive and non-cognitive, and say, is there a potential trade-off here? And I'll get to that, and we'll talk about it. It turns out, I think I'll say it in the next slide. See, I almost did it again. And then we'll conclude with, how does being assigned to a teacher who has higher grade inflation, how does that affect students in the future? So we're going to look at high school future test scores, high school graduation, college enrollment, college graduation, and early career earnings. So we'll be able to go all the way to that. Yeah, Doug.
So it seems like
They're coming.
the mean grade and the passing grade inflation together seem to, but they're not quite capturing the what I think of as grade compression.
Yeah.
That it doesn't discriminate anymore. Like, it's not related to ability or effort or your knowledge, right? And
Yeah.
somehow capturing that, if it all just goes, if it used to be 1 to 10 and now it's 2 to 11, I'm okay. Right?
Yeah. This is a great point. Had this discussion a little bit earlier. I think it's a really good point. One thing I'll just say is it's coming, the exact number, but the average GPA in these two settings is lower than you might think. So the average GPA in LA is like 2.2, we'll get to there, and in Maryland is 2.7 or something like this. So I think like the issues that exist, particularly in selective higher education, where everyone's at an A or something like that, is not really what's happening here. That doesn't mean it's not interesting or that sort of thing, and we should think about if there are things we can do, and if you have suggestions about how to look at this compression issue. But I think that's not first order what's happening in our settings that we're looking at now, but I think it's a very interesting one. Yeah.
I had a question about just dual enrollment and how that would have played a factor in this. Like, if teachers are relatively easy in their grades on the high school side, but because their students are enrolled in dual enrollment classes and the rigor is higher on the college side, do you have any insight to that?
I don't know. That's a good question. I don't have a great answer to it right now. I don't think there's a lot of dual enrollment happening, but I could definitely look into that more than, that's a great comment. This is recorded, so I don't have to take notes, so that's like a nice, then I have to watch myself, which is pretty painful, so I don't know. Appreciate that. Okay. All right. So just to preview, to tell you what we're going to find, I'll talk more about them later. Grade inflation is distinct from teacher value added. Grade inflating teachers have somewhat lower cognitive value added and slightly higher non-cognitive value added than non-grade inflating teachers, okay? But the correlations are not particularly strong, okay? So they're 0.3 to 0.4 for cognitive value added and 0.1 something for negative 0.1 for non-cognitive, or the opposite sign, I should say. Mean grade inflation decreases future test scores and the likelihood of graduating high school, and it reduces post-secondary enrollment, employment, earnings. We'll quantify how much later as well. Passing grade inflation, you might think has some positive effects, like I actually am able to finish this class and then get a degree, get a diploma, etc. And we see that, so you're like less likely to be held back, okay, in the same grade, and you're more likely to graduate from high school, and initially more likely to enroll in two-year colleges, but ultimately we don't see increases in educational attainment or earnings. Okay, so there's this kind of, the policy, what you would expect from the policy, like I'm now passing my algebra class, that seems to play out, but it doesn't actually translate into kind of future gains in earnings or completion of higher education. Okay, what do we think our contributions are? We're going to measure the effects of grade inflation. Some people have done this. We think we have some meaningful improvements on existing measures, and we've also introduced this new concept of passing grade inflation. We're going to validate those measures, and then we're going to be able to look longer term than the existing papers have been able to look. We are going to contribute to the teacher effect literature. This is not my strength, so there's a lot of people who have worked on that, many of them in the room, this is another teacher characteristic that you can measure in your data set that goes beyond test score value added or even non-cognitive value added. A couple of things to note about this is distinct from value added in that value added is, I don't want to get in trouble here, but my view of value added is that it's kind of a black box. We don't really know exactly what teachers are doing in order to have higher value added. We have some evidence in some cases, but it's a little bit of a, if you tell a teacher, hey, start having higher value added, it's not clear exactly what that means, okay? Whereas grade inflation is something I think we have a little bit more concrete idea about what teachers are doing, and so that's a distinction as well. Anyway, so it is a teacher characteristic, but we don't think it's necessarily immutable. We think that this is something that could be affected by policy, though we don't have, we're not going to evaluate a policy change to grade inflation or something like that in this paper. Okay, so here's the outline for the rest of the talk. We'll talk about the data. We'll talk about the measures. We'll spend a fair amount of time talking about what they are, how to think about them, how we validate them, how they're correlated with the existing measures. Then we're going to look at the effect in the long term, and then we'll conclude. We have data from LA and Maryland. Okay, LA Unified School District is the second largest school district in the nation. These two data sets are, there are many similarities, but there's also some differences and different strengths. So the students in LA, a majority of them are Hispanic students, and the graduation rates are comparatively low, just over 50% graduation rate for the students in high school. Okay, so quite low. One advantage is that in LA they're tested yearly through 11th grade. So that's quite helpful for us for looking at test score sorts of things. But we basically don't have higher education or anything beyond like the SAT in LA. Okay. In Maryland, it's different in Maryland than it is in LA, a more diverse set of student demographics. Graduation rates are much higher, over 90%, but there's more limited annual testing in high school. So those are kind of the trade-offs. We have more longer-term stuff as well. So here you can kind of see what variables we have in different places. Coincidentally, the years trade off right there at 2013, but we cover, a long period of time. We're looking in high school. We have the expected things you would, have in a administrative data sets. Yes?
I'm sorry if you said this just now and I missed it, but when you say tests, thanks. When you say test scores, should we think about that as like end of course scores, or are these for graduation requirements? Yeah.
There are standardized tests that are externally marked. So these are not like in Texas it would be the STAR test or something like this. Okay. It's like the state level tests. I forget what they're called in California and Maryland. They also changed over time. But those are the kinds of tests we're talking about. They happen much more frequently in California in this time period than they do in Maryland. Yeah. Okay. So here's the average GPA. I was close when I was telling you the average. Okay, the average GPA is 2.29, and then 2.9. So in terms of compression, I think I'm not overly worried about that in Los Angeles, and even in Maryland, that would be in college. That'd be a very low. That's like an econ level average GPA. Couple of things to point out: the failing grade. A lot of people get failing grades in LA. Very few people get failing grades in Maryland. This is going to come up later, so I'm just flagging that now. Those are the main things I wanted to flag. Enrolling in college, graduating from college, and earnings. You can see that there in Maryland. Okay, yeah.
What does it mean to be held back in high school?
Yeah, it's a good question.
What does it mean to be held back in high school?
I could also repeat it, I suppose. It means that you appear in the next school year with the same administrative class. So you're like appear in ninth grade again, and you were a ninth grader the year before. That's what we're calling held back. You know, you're not taking all the same classes over again. You're likely taking some classes over again. We don't know exactly what it means, but
Like you haven't passed some key course that you need for.
that seems likely. Though we don't have we don't know for sure. It's not. I mean, it's going to confirm what we see kind of with graduation, but it's not like it kind of goes the direction we'd expect. Yeah, Sue.
Is this if you have at least one failing grade? Is that what this?
This is at. I think that's right. Yeah. So this is at the student level.
Just noting that the held back is bigger than the failing grade.
Oh, I'll have to look into that. Yeah. Thank you. Okay, so here's grades are increasing over time in LA and Maryland. And like I said, by coincidence, we have exactly 1 year overlapping, but you can see grades are going up from quite low in LA in math to still low, but they're going up. And then Maryland, the same thing. You can pick out COVID as well. True in ELA as well. Okay, so grades are going up, but not kind of, I think, not obviously having these ceiling effects present. Okay, so here's how we calculate mean grade inflation. Basically, we're trying to predict if your grades are higher than, are teachers giving out grades higher than we would predict based on student performance. That's the idea. So the object of interest is this thing in red, GIJT mean. This is for teacher J in year T, okay? It's you can think about it as a fixed effect for the teacher, okay? And it measures how much higher teacher J's students' average grades are than predicted. And what else are we controlling for? We're able to control for their test score in the course that they're taking. So we know, okay, you did this well on the test in this student's, in the test associated with this teacher's course. That's controlled for here. This is the grade in the same subject in the year prior. So perhaps a student is just very good at something that's not measured well by tests, but is measured well by grades, and their previous teacher had measured them as doing well on that. We're going to be controlling for that, okay? We use the prior math test score as well, and also English. So we have controls for kind of the prior year math and English tests. And then we have student demographic characteristics, we have limited student demographic characteristics in LA, but they don't matter very much. But we also control for school fixed effect, grade fixed effect, year fixed effect, EL status, English language status, lagged fraction, blah, 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 those things too. Yes?
Jeff, sorry. So normally in a value-added equation, if test scores were on the left-hand side,
yeah,
it had become conventional to include a regressor for the mean student achievement. And actually now, I'm not sure that's best practice anymore. But in this instance, especially if a grade might potentially be, there's a curve going on.
yeah,
Having some kind of measure of what were the characteristics of the other students in
interesting,
the class.
yeah.
Because I was just thinking, okay, how would this go? So say if not having that, could the grade, a high grade mean, okay, this was a class with weaker students, and could that then become a signal that is then related to some of the later outcomes? So
let me talk through one example of that, and then, but that's a good point I need to think more about. Yeah, but I think that's a good, thinking about the curve aspect of it. Let me just say this really quick, and then I'll get to your question, because I think it's related, and then, so I think Tom's picking up on this, it's a residual. It's kind of this thing after we've controlled for things, okay? I think actually the one that Doug, last time he saw this presented, pointed out was PIERs, I think, as a thing to think about, okay? Most candidate omitted factors would bias us towards positive results. So if we think that I have unusually good PIERs, and that's why my grades are high, okay?
or low,
Well, yours is a different one, but like I think many candidate ones are like if I have unusually good peers, and that has a positive peer effect on me, and so my grade is higher because I learned more and that's showing up, that would actually bias us towards saying that's a grade inflating teacher. We're going to find that they're not. That's bad, so that's kind of going the wrong way. You could think about like, oh, the teacher teaches you how to work in groups really well or something like this, and so that's why you have high grades because she's like focusing on the fact that you're working well in groups, and that has positive effects on your future, but not positive effects. But that again is going to be kind of the opposite. Yours is interesting because it goes kind of the opposite way, I think, and I'd have to think more about that. But this idea of curving, I think, is useful. Sorry, Doug. Let's get to.
Appreciate it. So something that I'm thinking about that I would love clarification on is how should we be thinking about teachers changing the courses that they're teaching, and such that like if, let's say 1 year it's still in the same subject, but like what if 1 year you're teaching calculus and then next year you're teaching algebra 1 or some other course? How would that factor into all of this?
Yeah, so that's a great question. We're saying that a teacher has a fixed characteristic of grading. So this is not, it's not like they have a subject specific, like I have an algebra 1 grade inflation and I have a calculus grade inflation. So they have subject specific inflation. So if they do things differently, we'll get some kind of weighted average of the two in the two different settings. But yeah, Doug.
So this is more just like another measure that might be interesting to look at that gets at kind of a compression, but at whether grades are related to what we think they should be, would be if you let the coefficient, like the simplest version would be teacher-specific coefficients on test score.
Okay.
So like, are some teachers, that's kind of like a compression. Grades aren't very related to this other measure of how you're doing in the subject.
Yeah.
It's not perfect. I mean, there are a lot of reasons that might be. It might be this teacher rewards something else.
Yeah.
But I just wonder, that's why I think of it as just another measure that might be of interest.
Okay, yeah, I like that. Thanks. Okay, so this is what it is. So if you have questions, you should ask them here. But basically, it's saying are grades higher than we'd predict? That's the idea. And this, I also wanted to point out one thing really quick, Peter. But this looks a lot like value added, in at least in some ways, but it's different in an important way, which is the thing on the left is chosen by teachers. And that's kind of the whole point of this, is that they're making a choice about the grades they're assigning students. That is like very different than teacher value added. So there's some similarities, but I think like that's just worth pointing out. Yeah, Peter.
Are teachers also grading the test? Like a different set of teachers, but from the same?
No.
These are just
No. This is like a bubble, like Scantron sort of thing.
I see. And then is there a way to think about any kind of inflation in the way that those tests themselves are being graded?
Yeah, so that like, talking to a psychometrician about this stuff, we are just taking this as saying, we have these fixed effects for year and grade and school. So this is kind of within a year this teacher has higher grades than we would predict within this year, which is the same test. So, yeah, that's like, so there are papers that look at like they try to measure grade inflation by looking at, say, comparing how students are doing on the SAT over time, and then you really need to make sure the SAT is the same thing over time if you're doing that sort of thing. Here we're we're looking at cross-sectional variation in grading, and so we can we're leveraging that. Passing grade inflation is the same thing, but instead of putting on the left-hand side just your grade, we're putting an indicator for passing. Okay, so that's what that is. I don't know, there's not a whole lot more to say there, other than I think we focus on passing. You could do a lot of different things, as I've alluded to, but we focus on passing because it has a particular policy relevance. You cannot get a diploma if you don't pass particular classes. You don't get credit for the class. There's like and there's this kind of mechanical thing that I can keep going through school if I pass. Here's the mean grade inflation. Oh, yes, sorry.
Sorry, similar question, just one more time.
Okay,
Like,
I'll try better. I'll try to do better this time.
If you go back one.
Yeah.
It sounds like what you just described was like there's certain courses that have like this sort of grade inflation component to them, but here we're talking about them as if they're the teacher's choice.
Yeah, that's right. We're doing it definitely at the teacher level.
And so I'm just like trying to wed those two. It's like do you see this as like the course itself is creating these conditions, or is it the teachers?
The way we're teachers are creating these conditions, and so teachers, we're saying, have the same effect if they're teaching different courses. Yeah, the same kind of propensity to inflate or not inflate grades. Yeah.
Thank you.
Yeah.
By the way, Jeff, I think you could, so Tekka's question, I think you could test that by saying, okay, if I see a teacher teaching a different course.
Yeah.
Did their grades from Algebra 1 are, I think you will do later on this forecast bias test, but like you could do that across
Within a
courses.
year across courses, yeah. We thought about, I should maybe not open up this Pandora's box of, but we thought about doing mover stuff or something like this too. It gets a little bit, we haven't gone down that route, and it has that flavor there, but I think it's a useful thing for us to think more about. Oh, yeah.
Sorry. I'm sure it was mentioned earlier. I just wanted to clarify, these tests, they are standardized tests.
Yes.
Are they externally marked
Yes.
or by teachers?
By not the teachers that you have.
Okay.
Yeah. So you should think about them as I fill out a bunch of math bubbles and then it gets scanned. And
Got it. So I'm just thinking about the bias of the classroom teacher that they might have, or leniency.
not using those tests. We're using the tests from externally graded.
Got it. Thank you.
Yep. No, that's a very important point, so I'm glad you clarified.
I'm trying to remember the policies in California at the time at the high school level. Who was using those test scores for what purposes at the high school level?
I'm not the right, I don't know the answers to that. Some of these are going to be required, I think, for graduation, potentially, but not all of them. They have them in kind of classes so California is doing more than kind of is required federally, and so I'm not sure what they're doing with those, but that's a good.
This goes to, I was trying to think about Peter's question about inflation. Like there were no stakes for teachers on those tests.
Oh, Nolan would know the answer to that too. There were value-added incentives for teachers in LA. I don't know what years those overlapped with this.
I think this is 2003 through 2013. I don't think they were doing.
Okay, happy to report they were not. So I don't know, but that's a good question. I don't know the answer to. Okay, so how much, this is going to come up later, but this is showing there is variation in this thing. These are, I went over this quickly, these are jackknife empirical bays, so these are shrunk, okay? And so this is the variation in this thing. You can see in LA and Maryland, this is for math. It's a little bit different in LA and Maryland. It's about 0.4-ish for LA, so 1 standard deviation increase in grade inflation is about a difference in GPA of about 0.4 in LA, and about 0.2 in Maryland. So when we talk about the effects of 1 standard deviation, that's kind of what we have in mind, okay? This is for passing for math. Maryland, there's very few people fail, which as I mentioned before, we're still gonna have variation in this, but just know that's happening, okay? So Maryland doesn't fail people. Okay, so yeah. Okay, I'm glad you think so. Okay.
I'm just saying this is really big. Like, this is a 50 percentage point spread in passing, depending on
these
what
are in. Oh yeah, yes, that's right.
in passing.
Yes, passing.
And the other one was like.
This is GPA points, but yeah.
2 GPA points, depending on which teacher you get.
Yeah, we should ask the students if they've had that experience. Ask my students versus someone else who taught intermediate econ or whatever.
Have you guys looked at all at how much of this is within school versus between?
We have not done that. That's a good question. Yeah, that's a good question. We have mostly, people want to know about schools. We haven't done as much with them. We could do this within versus between just for this thing. But yeah, it's a good question.
By the way, that could be related to the point I was making about the curve.
Yeah.
In that if I come from a low-income high school, a given test score might allow me to have a higher grade if I'm coming from a school with students with much weaker academic preparation. And that then could be negatively related to some subsequent outcomes, but it's because of the school.
Yeah, we do have school fixed effects in everything we're going to do.
Oh, okay.
Yeah, but that's a good point. Okay. Okay. So we're going to do forecast bias tests. These are like value added. You could so you can suffer from noise from estimation error or bias from selection on observables. I'm not the expert in the room on this stuff, but I will muddle through. Okay. So we're going to do two common tests. We're going to do an out-of-sample forecast bias test where we regress residualized GPA or passing indicator on grade inflation measures and see if the coefficient's 1. That is, if our measure predicts kind of in the year that we didn't use. That's the first one. And then the second one is we're going to test for selection on omitted observables, where we're going to use twice lagged and other things, but we're going to use twice lagged test scores to see if students are sorting to different teachers with different grade inflation on the basis of twice lagged test scores. So a little Rothstein-esque ish on that. Okay. I don't want to say that too loudly, maybe, but yeah, I mean, that's the flavor of the idea, right? Is that kind of thing. So the first two are these. This is for LA and Maryland, and you can see that these are close to 1. These are very similar to kind of estimates in the value added literature produced in-house in this room. But you can see that they're close to 1. They're not 1 we can sometimes reject, but they're not huge. Okay, you can decide if you find that kind of test convincing or not convincing. I think this, this selection test is is a nice test. It shows that there's not really selection into teachers on the basis of twice lagged test scores. Grade inflating or non-grade inflating teachers on the basis of twice lagged test scores. We've subsequently done this in Maryland. They don't have twice lagged test scores there, but we have other things we find similarly that it does not look like on the basis of other demographics or other characteristics of students. It doesn't seem to be sorting. So that's nice, I think.
So Jeff, I think because several of us do these forecast bias things, I think you may have undersold this table.
Okay. Okay.
In that,
happy to, yeah.
In that, you're saying, okay, you see a teacher work with, one group of students. You infer that teacher is either has high standards or low standards.
Yep.
And then you say, okay, I'm going to take that same measure and say, all right, when that teacher is teaching a different group of students,
yeah,
did their grades follow what I would have expected, even controlling for students' test scores? And the answer is about right on average.
Yeah, okay. It does. So I'm happy that you I like this test. I think it's compelling. And it's different than value add. I mean, it's the same sort of test, but it's a different thing. It's and I think that is useful. Yeah.
So Jeff, given that you're going to tell us about long-run outcomes, the treatment, such as it is, of having a grade inflating or not teacher, can in fact affect long-run outcomes, not just through the sort of proximate experience of getting a high grade, but like future teachers or future experiences. So one observable that you have is, are students, that I think you could do, is are students being sorted in some dynamic way over time to teachers based on this sort of grade inflation measure, right? Like if I'm a principal and I say, oh, well,
I've got an answer for you.
He had Eric. Eric's a hard grader, so I'll give him to Jeff next year.
Yeah. So we look at, for a student, what is the correlation of my grade inflation experience, grade inflation over time, which is, I think, what you're getting at. it's on a later slide, so I won't know the exact number, but in one of, I can't remember if it's LA or Maryland, there's no statistically significant relationship between my grade inflation that I experienced this year and the grade inflation I experienced next year. In the other one, it's like 0.1. It's correlated, but not very strongly. So it does not seem like you get unlucky twice or whatever, right? Like you're not like, so like in terms of interpreting this, it's going to be like a 1 year. This is a 1 year thing. The treatment is 1 year. Does that make sense? Because it's not correlated serially. It's not like, oh, if I get on this track, I'm always getting the easy teachers. Okay, we do value added. Okay, we do cognitive value added. We're making no innovations here. So we do value added, we do math and English, and we do an index of them together. We do non-cognitive value added. This is using the same data set or at least half of it, that Nolan and his co-author did on their paper on non-cognitive value added. This is things that are related to, teachers might raise that are not test scores, like effort GPA, cooperation GPA, suspensions, etc. And we use, in the event that we're using next year values of GPA and effort GPA and that sort of thing that Nolan does, okay? And then we use an index of these 6 value-added things. So we're just off the shelf with those. Okay, so here's a result, okay? One of the first results, okay. So let me stand over here. I guess I don't know why I'm standing behind there. I don't have to. Mean grade inflation and passing grade inflation are highly correlated in LA, okay? They are not perfectly correlated, okay, but they are highly correlated. By the way, these are fancy correlations. These are bootstrap split samples to deal with attenuation, okay? If you care about that, we can click on that button. Okay. Maryland, they're less highly correlated, and that's, I think, in part just because there's less variation in passing grade inflation, okay? But mean grade inflation and cognitive value added is negatively correlated. So if I'm a higher mean grade inflating teacher, my cognitive value added is lower. Now, we're not saying this is a causal thing. These are just kind of descriptive, but that's worth noting, okay? And non-cognitive value added is slightly positively correlated with mean grade inflation, okay? So teachers that add high non-cognitive value, they tend to be, grade inflating teachers, okay? But not strongly, not a strong relationship. So, the reason we were interested in this is if they were causal, does this represent some sort of trade-off, right? Like, well, I'm a grade inflating teacher. This is like coming from me being a professor. Like, if I'm giving out low grades, like my students don't like me, and so maybe they may not, invest in these sort of I might not be helping them come to class, or they just don't like the experience or something like that. That's kind of the direction of the non-cognitive value added relationship there, but it's not super strong. Okay. All right. I think those are the 2 things I want to point out there. You can see other correlations. Passing has similar kind of general patterns as mean does, mildly correlated. But I think the one thing to take away from this is it's not value added. Okay. So it is a different thing happening. Yeah.
So just a note, I mean, you have very reduced variance, as you said, on the passing.
Yep.
So there are also corrections in addition to measurement error. You can just correct for the variance and say, what if the variance were the same on passing as it was in LAUSD? And that's an extrapolation, but it might help you make that comparison more apples to apples.
Yeah, thanks. I mean, I think it's still going to, I'll show you. They have... Well, I'll come to this, but we're going to look at the effects, and they actually look very similar in the 2 places, despite them being kind of different, different amounts of variation in the 2. I don't think I talked about this, but I can talk about how ours are correlated with existing measures. So, like, there's an existing measure by David Figlio and a co-author. Ours are, anyway, they're not that correlated. They are correlated with those, but actually not super correlated. And I can talk about that if people are interested, maybe after. Okay, how are we doing on time? Pretty good, okay. So we're gonna just do kind of a horse race type regression. We have some outcome. We're gonna control for mean grade inflation, passing grade inflation, cognitive value added, non-cognitive value added, and then exits, okay. This is very similar to Chetty, Friedman, and Rockoff, and Nolan's paper, and many others at this point. These are the main coefficients of interest. We need conditional random assignment. We are conditioning on some important things here, so we think that is plausible, but that is the assignment. We use the same controls as in the value-added estimation. We do the jackknife thing just as a reminder, so that means that, it addresses measurement error concerns, but also these kinds of like, my omitted variables causing, it solves some problems associated with like me being potentially on the right and the left if I do the jackknife thing. Okay. All right. Here's the effects. These are coefficients and standard errors, our 95% confidence intervals. Okay. In LA, we see reductions in tests for mean grade inflating. So that's the blue circles. Maryland, we don't see it as much, but we also have many fewer kind of repeat observations of people taking tests because there's just less testing going on. Okay. Passing grade inflation means you're less likely to be held back, okay, administratively. Mean grade inflation doesn't really have a relationship there. Okay, so that's like goes the way it should. Mean grade inflation makes you less likely to graduate, okay, whereas passing grade inflation makes you more likely. It's kind of marginally statistically significant in both cases, but kind of directionally is you're more likely to graduate from high school. You can see taking the SAT for Maryland, it reduces it. It's kind of, again, close for LAUSD. I should also mention this is while we're controlling for all four of these. In the paper, we have where we just do each of them on their own. They have all the expected signs on their own, and they're bigger then, but this is kind of saying, holding fixed your value added, right? What's the effect of grade inflation? Yeah.
So, like, even if students were randomly assigned to teachers, you would still be concerned about omitted teacher variables. That is, other characteristics of teachers that you're not observing here. So, like, we're calling this grade inflation, but it could be, like, teachers who are just not giving much effort at work, and they don't give effort to lots of things, including deciding what grades to give. Now, part of that is
value-added,
addressed by value-added. But so the one thing I was wondering but here we're getting, like, the average coefficients. So I would be interested to see, like, among low value-added teachers, there will be some relationship between grade inflation and long run outcomes.
So like heterogeneity.
High value-added teacher. So is a high value-added teacher arriving at grade inflation for some reason that's different from a low value-added teacher arriving at grade inflation?
We have not done that interaction. We could. I think that's interesting. But that's, I think, the way you test it is some kind of interaction or split sample or something.
Can you put the chart back up again?
Sorry. Yep.
So can you give me the intuition on why the mean grade inflation versus the passing grade inflation have different signs on graduation?
So for graduation, it's saying you passed. So I gave you a passing grade when I otherwise might not, and that is good for you because you got the credit in the class. For mean grade inflation, you learned less in my class, and so you maybe now learned less, that subsequently harmed you in future classes you took, and so now you don't graduate. These are, again, holding fixed, the other one, which is a little bit kind of, you have to wrap your mind around a bit. Okay. This is just saying, So now we want to say, we want to look at the effects differently by student ability or student preparation, however you want to say that. You could imagine it affects differently. The effects are different for top students versus not top students. For mean grade inflation, it could be that it's like for, mean grade inflation is more important for human capital accumulation at the top versus the bottom. You can tell stories either way. Or it could be uniformly because the effort is likely needed for each grade. If I want to get a D, I have to do this much work. If I want to get an A, I have to do that much work. For passing grade inflation, though, we think that the effects on graduation and being held back should be concentrated among kind of less prepared students. Okay? So for mean grade inflation, there's not a lot. So this is above median 8th grade GPA and below median 8th grade GPA is a simple cut. There's not a lot of differences, honestly. So it doesn't look like mean grade inflation has much differences in terms of its effect on short-term outcomes here. Whereas for passing grade inflation, you can see that the below median students are less likely to be held back if they have a passing grade inflating teacher. Slightly more than this, but not a huge difference. Where you really see it is in graduation. Okay, so low kind of students who are at risk of not graduating are really benefited or really made more likely to graduate by having a grade inflating teacher. And that's true also in Maryland, even with our less variation in graduation and in passing, but we see that same pattern directionally, though, much smaller magnitudes.
So
yeah. I should just have them right here.
Just thinking ahead, this is very much like, okay, we're going to let you get through and you're going to get your diploma. You aren't learning that much, but that's fine.
Yeah.
And you could imagine why that would help you a lot get into the 2-year college.
Yes.
Right. So so I should think of this as telling a consistent story.
Yeah, I think so. Yeah.
And the community college is really about the below median.
Yeah, I don't think we have that split coming up. We could do it easily, but I don't think it's in the table, in the slides. But that is the idea.
Yeah.
Okay, so let's look at post-secondary outcomes. Mean grade inflation makes you less likely to enroll in high school, 1 year post-high school, 2 years post-high school. No effect on graduation in 4 or 6 years. Passing, there's not a strong relationship here. It's positive overall. That's being driven by 2-year colleges. I'll show you next. Although passing has negative effects on graduating 6 years post-high school overall. You can see this is being enrolled in an associate's degree in each year. So this is year 1, 2, 3, 4, 5, 6. You can see that it makes you more likely, passing grade inflation makes you more likely initially to enroll in an associate's degree. Mean grade inflation is just you don't go to college at all, you don't go to an associate's degree, and it kind of looks like you don't go to get a bachelor's degree either. Okay, so it reduces your enrollment. This is, depending on which year you look at it, this is statistically significant for passing grade inflation. We have a slight positive effect on getting an associate's degree. It's very small, I will note. And for mean grade inflation, this is just bad for your associate's degree. No effect on bachelor's degree for mean grade inflation, but kind of a consistent story here, I think, of it just reduces educational attainment. Mean grade inflation does. Passing helps you go to an associate's degree, maybe get one, but it's kind of marginal. That's the idea. I like to say I'm a labor economist, so I like looking at earnings. That's kind of we spent a long time getting the Maryland data to be able to look at this. And I think it tells a pretty interesting story. You can see 1 year post-high school, mean grade inflation makes you less likely to be observed having employment, okay? And that's still true actually 6 years post-high school, okay? So we don't think this is about migration or something. This is right after high school. They're just less likely, it could be, but it's most likely they just didn't, they're being harmed by mean grade inflation. On earnings, you see a similar story. Okay, passing grade inflation, there's no effect on earnings. That's kind of a consistent story. Yeah.
Have you looked on whether this varies by the timing of exposure to an inflating teacher?
We have we're limited a little bit by that because there's you have to take a test in order for us to know that you are experiencing grade. So we don't have any 12th graders basically because they mostly aren't taking tests. But we could do 9th, 10th, and 11th. We have done that. My memory of us doing that was just kind of noisy to try to separate all of those out, but it's not currently in the paper. Okay, so this is the main result. I think this is, when we presented this before, the question is is this big or small? And so the next slide is going to help us think through whether this is big or small. Yeah, Doug.
So how should I be thinking about the college 2-year stuff and how that's interacting with employment and earnings? Because this is, at 1 year, it's for sure, if people are going to college, it's affecting their earnings and employment.
Yeah, so yes, but we generally find they're not going, right? So they should be more likely to be working. They're not going to college, so they could be working more.
Yeah.
By year 6, we're hopeful that most people are either That's about as far as we can go in the Maryland data, for better or worse, with much coverage. And we're hoping that, that's kind of you're out of college if you're out of college. So 6 is better in that respect. But I think if you were worried about substitution between the labor market, it would be positive. I'm more likely to work because I didn't go to college and didn't get in.
So in some sense, these are I need to combine them to think about the total effect.
Combine.
Meaning you're not going to college, maybe you're going to 2-year for some of the things.
But then, that's right.
And by 6, you're not going to college and you're earning less, you're working less.
Yeah.
Okay.
Mm-hmm. Okay, so let's do some, this is the kind of new, if you've seen this before, my apologies, but this part you haven't seen before. So this is kind of thinking about what the size of this is. When we presented this at NBER, we got a lot of comments of isn't this tiny? So no, is going to be our answer. So this was to Eric's earlier question. Grade inflation measures are not correlated over time. For a student, small and insignificant in Maryland and LA, they're kind of, 0.14. But so anyway, so you should think about this like these coefficients are for 1 year of exposure. Okay, how big are they? So this is the effect. So we want to know the effect of a single teacher increasing mean grade inflation by 1 standard deviation for 1 year. That's the benchmark we're going to talk about here. And we're going to borrow from Chetty, Friedman, and Rockoff to kind of use the way they do this is very similar to what they talk about, or at least in one of the things they talk about. They talk about a lot. They had to do 2 papers, in fact. Okay, what do? We take the present discounted value of lifetime earnings, assume the effects seen years 1 through 6 post-high school persist on earnings. It turns out, I didn't show you 1 through 6, but they're always about the same percent decrease from the mean. So it's always like a 0.7 percentage point decrease. Okay. Multiply by the number of students. There are 91 students that a teacher sees. Okay. And then divide by the number of teachers, which is 2. So that's how we get our number. So 1 teacher inflating grades by 1 standard deviation for 1 year implies a loss for their students of $162,000 in present discounted value. So that seems bigger to me than what people were worried about. I think, there's a lot of assumptions baked into this. I don't want anyone to take this as it's kind of silly to have it down to the, that 61, not 62 or whatever, but that is the number. So, I think just to give a sense, this is pretty important in terms of its effect on earnings. We didn't, if people I'd be interested if people have different opinions about what we should do as policy. I mean, I'm sure referees will tell us. We're going to submit this here soon, hopefully. We don't do teacher deselection or any of these other things that are common in the value-added literature. That doesn't really, I think, make a ton of sense necessarily in this context. But if you have some other thing to think about, that'd be interesting. Yeah. Deselection, I always think that's a funny...
I wonder also some calculation about how disparate the impacts are within kids who just by chance get a certain string of teachers.
Oh yeah.
So I know we'd done this for our econ majors.
Okay.
When we were doing grade inflation in college, and it was shocking how kids who just by chance had certain instructors, how different their GPA would be, and then what that would translate. So kind of how this is leading to inequality,
yeah, I mean,
random inequality.
Yeah, I mean, if you had a bad string, you could, I think it's linear, so I think you could just multiply it by 4, basically.
And by the distribution of what kinds of teachers people get.
I see.
So it's in those 4 teachers.
Yeah, okay.
Some people get. Yeah, what are the 90th percentile?
Yeah. What are they actually? When you're flipping the coin 4 times. Yes.
I mean, the other thing that comes to mind is if this is some sort of strategic, conscious plan on the teacher's part, maybe you can't change it. Maybe you can change it if you tell them how much they're harming their students. But if it is a sort of cost of effort problem that we get to the end of the day and we go home and we hurry up and finish the grades, right? there's a lot of money for if that class could get together and pay the teacher more to stick around for an extra hour and think thoughtfully about the grades.
That's the most econ question of the day, or comment of the day, I think. Markets for getting your teacher to grade you more harshly. Yeah.
I don't take credit for it. I think Chetty Friedman and Rockoff make a similar argument.
Well, this one's just kind of stranger because it's like not working harder to teach you. It's like, working harder to give you harder grades. Or, like it's this like, will you please give us worse grades? We would give you $162,000 to have worse grades. Yeah, we had a couple of questions in the back.
Do you know if there's any hysteresis? So for example, if there's a grade deflating teacher, do you see that there are going to be these positive effects for kids, or is it just that we want to get this to zero? So for example, like could you split it where your fixed effect, you have like a separate effect if it's positive versus negative to see if there's any kind of hysteresis? Because one of the things from a policy standpoint that we might wonder about is what if we were to deflate grades to get us back to the zero? Is that the right thing to do, or just to stop inflating?
Yeah, so that's a good question. We haven't done the positive negative thing. That's an interesting point. I think one thing just to point out, this is cross-sectional inflation. So this is like the nicest or easiest teacher versus the least nice. So we're not saying necessarily over time. We're just saying kind of directionally going towards the nicest teacher is going to have these sorts of nicest. The most lenient teacher is going to have these sorts of effects.
I think then it might be useful to use the leniency word too, because normally when people think inflation, they think time series as opposed to cross-section.
Yeah. That is, we've talked about that. It's a good comment. Leniency, yeah, we in the paper, we call it both. I didn't do a good job of kind of saying it's kind of this, but it is this cross-sectional idea. And it's not, yeah, so that's worth pointing out, I think. Yeah, yes.
So kind of thinking about the locations that you were looking at, I was curious about, in Texas specifically, they have like automatic admission for the top 5% students, right? So what does that how does that play into grade inflation in those school districts? I mean, we're talking about teacher value added or teacher leniency, so to speak, but if the pressure is coming from a policy external to what the campus is driven by, right? Like the kids want to go into school, automatically admitted, and then California just passed the law that gave them like direct admission as well. So what is that?
The direct admission law in California was not particularly binding over this time period. And then just to be clear, half of this is Maryland, not Texas. I don't think Maryland has the same thing. And Texas is a rank, so it's like it's about your rank in high school. So it's like there you have to actually like order the students, and there's a bunch of questions about how to do that. But I think that different contexts could give you different answers. I think that's absolutely right. Sue, sorry.
So can you like how is getting an inflated grade once in high school resulting in lifetime earnings decreases? What is going on here?
I mean, the thing that we show.
Dunning-Kruger, in which case, have you done this by gender?
We haven't done it by gender. That's a good question. I think that I think they learn less. I think is the big. We show that they do worse in the future. They're less likely to graduate from high school in the future from a mean grade inflating teacher. So I think we're not just showing the earnings result. We're showing kind of along the way. There's these kinds of checkpoints where you do worse on future test scores, you're less likely to graduate. And less likely to enroll in college, your favorite, that has high returns.
So couldn't you sort of mess with that a bit by trying to control for some of like the most final measure you have of, say, high school learning? Right, if you think it's basically a permanent hit to how much they've learned, then if you have some measure of that,
we could do some mediation sort of thing.
And see if it's still there.
Yeah, we haven't done that, but that's a good suggestion. Yeah. Sorry, there's like I'm not in charge of the mics. Okay.
I had a question.
I can hear you.
Great. I had a question sort of related to this relationship to state policies about enrollment and stuff in higher education, and I guess what I'm wondering is, so I guess maybe implicit here, right, is or maybe not, is the idea that the relationship between your grades and your access to higher education remains constant for all of the observations in this data set. And I think I'm wondering, I don't remember if COVID happened in this, but I think even if it didn't, I'm curious, like, if there are sort of system level changes, like either in the state of Maryland or California, wherein like a person's GPA matters less at over time, more over time, right? What we might be capturing is like a time trend in the relationship between GPA and this versus the actual effect of the grade inflation on the longer term outcomes.
Yeah, so we do control always for time effects. So anything that's happening kind of to everybody, that should be the same. It is, you are running into COVID at the end of the Maryland data. In general, most schools are not that selective, and so are not like being able to hide your grade, or mostly going to college is about just going to kind of a college that's not particularly selective. That doesn't mean that there aren't people for whom this is an important thing to think about, so we'll have to think about it more. But I think, most people are going to kind of non-selective schools, and so I'm not sure that having like hiding your GPA or GPA being different because of COVID is going to have a really big impact on your admissions. Where that, I think, is, if you're thinking about getting into Dartmouth, there's some good evidence that there's, thinking about how to hide stuff is useful. Or not useful, yes. Yes, Tom, sorry.
So I'm going back to like Sue's question. Like, so it would be nice if there were some more direct evidence on the mechanism. I think the evidence you're citing is, well, we see that grade inflating teachers have smaller effects on value added. But so I think your theory is if I'm a weak grader, kids are just working less. If a kid knows that it's easier to get an A, I'm just going to invest less time. There are some data sets, like in North Carolina, in the 2000s, there was a student data questionnaire that students filled out as part of the when they were sitting down for the state test, that asks about how much time they spent watching TV.
Interesting. Okay.
And like, certainly, I know that's not in your data, but like, that could be a place where you could sort of test this, where being assigned to a weak grade.
Yeah, I like that a lot.
Teachers, that mean I get to spend more time watching TV. But I was also wondering whether in the NAEP there's something you wouldn't be able to do it at the student level, but maybe at the school level, some relationship between the test scores, and the students do self-report grades, I believe, on the NAEP. And then I think they also report some other things that could be related to time spent studying. But like tightening up, because I share Sue's concern that right now it's sort of like you used the term before, a black box. Like, so yes, at least we're confident that teacher is having an effect.
Yeah.
We're not sure what they're doing differently. Here you're trying to make the case that the teacher's grading practices is leading to these later negative things, but it would be nice to tighten that up by saying some more about, okay, and here we show evidence that they're working less, and
I agree. I think I agree. It'd be nice to have these sorts of time use sort of things, or effort sort of things. Thanks. I will just point out, we do show things it's not like we only have earnings, right? We show that they do worse on tests later. They are held back and graduate, they graduate less, and they're less likely to go, on the next slide, they're less likely to go to college. So I agree that it would be better to have more, but I think it's not you could imagine a version of this that only had earnings, and I think that would be perhaps harder to believe, but did the actual magnitudes line up here? I think is a reasonable question. Like we're saying there's this much reduction in test scores, this much reduction in graduation for a student, and then the effect on earnings is like 0.6% or something. It's not a huge effect on earnings. It's just that you're teaching 90 students and you.
So can you use the correlation from previous literature between test scores and earnings?
We could do.
Try to partial it out, and for that matter, return to going to college.
Yeah.
And see, does it line up with that?
Yeah. So
Stick it down the right-hand side.
we could do that for sure. I think like just the number on high school graduations is going to be enough by itself. Like because you have to choose which one of them you're going to do, right? Like is a high school graduation, is a college. I mean, maybe you could do something complicated where you do all of them together, but like. I think any one of these is going to give you a 100. So our estimate for earnings is $130, negative $130. So
what, lifetime or?
$130 so it's 0.6 percentage points in earnings 6 years later. And we have reductions in graduation of 1 percentage point from high school. And we have, increases in tests of whatever. So I think like we can get there pretty quickly. But you'd have to choose which one you want it to be.
A way to try to get at this is to look at heterogeneity by student type. Is the type of student that is not graduating, that is the one, the cells that change in earnings.
Yeah.
So work some with the heterogeneity if you can. And I was being actually serious about the male versus females.
Okay, yeah.
As well.
Yeah.
Can I follow up on the male? No, I can't. I think the male-female is interesting because there are these other things which find that men and women respond differently to feedback, right? And well, yeah.
Like, so looking at what they have in college, if you can do that.
We can't.
These experiments.
We could do that. Yes, I think my co-authors are wincing as I say that. I think, but. So I agree that it is kind of, we are looking at this, and I just wanted to kind of come back and say we have kind of a causal chain here of things that are happening along the way. It looks like, that are much more proximate to the teacher and kind of correlated with the things that we expect. The point, though, is well taken that we don't have, like, they studied less or this sort of thing, but we're not... We only have to explain a reduction in earnings of $130 per student, and these coefficients, just by looking at them, are going to get you there, I think, pretty quickly. So anyway, but that's good feedback. The last time I did it, it was like these are too small to be interesting. This time it's like these are too large to be believable. So we're gonna, that's right. Yeah. I'm getting the pitch right. Yeah.
So I was wondering, and sorry if I missed this on a model slide or something.
There was no model slide.
I just want to check, this hasn't been thought of this is the effect of deflating grade by 1 and you get an increased earning, like stricter teachers, like on the left side of that distribution aren't going back to the history thing of the teachers that shrink grades versus teachers that inflate them and, all that variance.
So I'm not sure I follow your question exactly. So
if you flip the sign and you say, okay, teachers that decrease.
Oh, yeah. This is just taking moving up 1 standard deviation in the distribution. So this is assuming it's the same throughout, going from 2 standard deviations to 1, below, -2 to -1, 1 to 0, 0 to 1. We're kind of taking all of those and saying it's linear. That's what we're doing right now. You could do some, we're going to not have power to do that, but you could do something where it's like, is it different?
Right.
Different?
It's more of a framing question, though, of if you can go that way or you can go the other way.
Yeah. So this is saying if you get stricter, it's good. If you get more lenient, it's bad. I'm fine with either. Yeah. Great. These are great questions. This is fun. Yeah. It's fun. Yeah. All right, let's see. I think we're doing good. We do a bunch of robustness checks. I'm not going to really click on them unless you have particular feelings about them. One thing I'll just say is we did this twice. This didn't have to, we kind of did one replication already. Maybe we could do another one in a different place. For the right journal, I would. But we get consistent results in these two places, which I think is nice. When we do the univariate thing, it looks very similar, which I think or it's actually much bigger because of its correlation with teacher value added. There are other things you can do. Math and English, we try to do that separately. We thought that might be interesting. They look broadly similar, just kind of more noisy, and so we don't find much difference there. When we have additional controls, it doesn't really matter. If we have higher order polynomials and test scores, it doesn't really matter. Focusing on only a single course, so there's this question about algebra, calculus. Very few people are teaching calculus. A lot of people are teaching algebra. If we do just algebra, it looks very much the same as it does here. So, yeah.
So one way to frame this, coming back to that grades are information, right? And so some teachers are giving fuzzier or more biased information than others. Now the effect of that should differ by the baseline level of how well informed you are about your own capacity, right? So, think about when we do information intervention, it's going to be based on baseline stuff. So gender was one I suggested, but class might be the other one.
Yeah.
So if you've got any information, you have...
We can in Maryland. We're going to have a hard time doing that in LA, but... That's good because we have the long-term stuff in Maryland.
Free and reduced price lunch?
We don't have that in LA.
You don't have, okay. And for the college stuff, no FAFSA?
No.
Okay.
Actually, co-authors are cringing, but yes, we do. We have not used.
In California, the FAFSA has the, the education of the parents. I'm just thinking that the highly educated parent, maybe they're going to knows the stuff, as opposed to the teacher's signal having more power for a lower class.
Yeah. I think that's...
These are the kinds of mechanisms that if you can find this stuff, it helps with the story about what's happening.
Yeah, I like that. I think, I think we should totally do heterogeneity by those things. I think there's an information story that you're telling. I think there's also an incentive story that might be different by these same things, right? So it's a little bit hard to disentangle those two things, but I agree that we should do heterogeneity because I think there'd be lots of interesting things to learn there. I've got 5 minutes still, so okay, yeah.
Just one other robust. You mentioned earlier that I think that some of these are used, that you've done stuff with school fixed effects?
I think all of them have school fixed effects.
They all have?
Yeah.
Okay, so all these concerns that, this is just a poor school and so they get better grades, that's all out of here once you're doing this. Any variation within, it's all school.
So they all have school fixed effects in them. Okay, all right, so, am I done? I was just going to conclude and say thank you. Okay, thanks very much. Really appreciate this. I think this is, we hope there's future work on this. This is a thing you can calculate in lots of data sets. You can think about doing this at different levels. You can think about doing this at the school level. You can think about policies that are directly affecting this, have effects. There's one paper out there like that. Anyway, there's lots of stuff to be done here, and we hope this is the start of kind of many papers to be written on the subject. Thank you very much.
So thanks, Jeff, for joining us. And I think the range of questions that you got, I think just reflected, everybody's interest and engagement in the topic. Rachel, remind me when the next, March 3rd? Okay. So the next seminar will be in this same room on March 3rd with Leslie Turner. Will be joining us. So thanks, and thanks, Jeff, and thanks to all of you for coming out.